Welcome to this explainer. We're jumping right into one of the absolute oldest, deepest mysteries in the philosophy of science today. It's a puzzle that's literally captivated thinkers for millennia, and we are going to break it down together, step by step. So, let's dive in.
Here is the big question. Does math actually exist out there in the universe, or is it entirely a creation cooked up inside the human brain? Seriously, take a second and let the philosophical weight of that sink in. When we count, or measure, or calculate, are we inventing something brand new, or are we just uncovering something that was already sitting there? When you look at the source material on this ancient puzzle, there are basically three major camps we can fall into.
Let's start with our first major camp, Platonism, which is all about the idea of discovering math.
For the mathematical Platonists out there, mathematical objects are completely real. They just aren't physical. Think of mathematics like a giant, pre-existing, invisible landscape. We don't build the mountains in this landscape, we just hike through and discover them. This perspective goes all the way back to ancient philosophers like Plato, obviously, but it was also held by brilliant modern mathematicians like Kurt Gödel. To a Platonist, the number 2 isn't something humans invented, we just found it.
Let's ground this with a really concrete example. 2 plus 2 equals 4. Under the Platonist view, if every single human being magically disappeared tomorrow, if our brains and our societies just vanish completely, this equation, it would still be absolutely true. Its truth simply doesn't depend on us being around to write it on a chalkboard.
And it goes way beyond basic addition. There would still be infinitely many prime numbers in the universe. A triangle would still hold all of its exact mathematical properties. The ratio of a perfect circle circumference to its diameter would eternally be pi. These are eternal truths. They just are. They exist entirely independent of humanity.
But of course, there is a totally different way to look at this. Let's move to Section 2, Constructivism, and the idea of inventing math. This view is pretty much the exact opposite of Platonism. Formalism or constructivism argues that no, mathematics absolutely does not exist out there floating in some cosmic void. Instead, it's something entirely constructed by humans. Under this theory, we are the architects. We created the numbers, we designed the symbols, we lay down the axioms and the rules. Just look at the number 7. That symbol is undeniably a human invention. Somebody at some point in our history decided to draw those exact specific lines to represent a concept. And we didn't stop there. We created all the complex notation around it, like writing out 7 plus 5 equals 12. From a formalist perspective, math is simply a highly sophisticated language. It's a tool, a system we built completely from scratch just to help us describe the patterns we see around us.
So this brings us to a massive core conflict. Platonism tells us math is a discovered landscape. Formalism tells us it's a constructed language. But here is where we hit a really fascinating roadblock. Yes, humans completely invented the ink and the symbol for the number 7. But did we invent the underlying relationship? Like if you have 7 physical apples on a table and you physically take 2 away, you're left with 5. That happens whether a human is standing there watching it or not. So, did we invent mathematics itself, or did we just invent the specific language we use to talk about it?
Which brings us nicely to our third position, a bit of a middle ground. Section 3, Structuralism, or math being discovered in physical reality. Let's picture this clearly. Imagine 3 rocks arranged in a triangle in the dirt. Maybe mathematical objects don't literally exist in some magical, invisible realm like the Platonists think. But structuralists argue that the mathematical relationships definitely exist right here in our physical reality. Nobody needs to walk up to those 3 rocks, point at them, and declare, aha, Euclidean geometry, for that spatial relationship to be real. It's there anyway. And we see these structures literally everywhere in nature. Planets orbit stars according to incredibly strict mathematical relationships. Ocean waves and sound waves exhibit flawless mathematical patterns. Even the way biological populations grow follows exact equations. Physical reality just naturally follows these structures. We humans merely come along after the fact, spot the patterns, and formalize them in our textbooks. Now, this leads us to a genuinely strange phenomenon. Section 4, the unreasonable effectiveness. The renowned physicist Eugene Wigner hit the nail on the head when he called this the unreasonable effectiveness of mathematics. Why is math so extraordinarily, unbelievably good at describing the universe? Honestly, it almost feels like we stumbled onto a cosmic cheat code. And there is no better example of this than Albert Einstein's theory of general relativity. Think about what actually happened here. Humans sat in rooms, using their brains, to develop highly abstract math, complex geometry, intricate differential equations, purely in their own minds. And then, years later, we look out into the cosmos and discover that those very same purely abstract equations describe the actual physical behavior of gravity and space-time flawlessly. It's incredibly strange. Why on earth should a purely abstract thought inside a human brain correspond so perfectly to the physical mechanics of a black hole billions of light years away?
To really crystallize the differences between our three camps here, let's run a quick thought experiment. Section 5, the extinction thought experiment.
All right, imagine humanity vanishes completely tomorrow. No brains, no spoken language, no books, no computers. Would prime numbers still exist? The Platonist gives a firm, immediate yes. The numbers exist independently of us. The formalist says, well, without humans there's no mathematical system, but they'll concede that the physical patterns remain. And the structuralist? They say that while our specific human symbols would disappear, the underlying structures and relationships of the universe absolutely survive. It's a brilliant way to separate these deep philosophical camps, right?
So how do we make sense of all this? We really need to separate two distinct concepts. Section 6. Language versus structure.
Take symbols like the number 2, the plus sign, the equal sign, pi, the infinity symbol. Humans clearly invented this language. We literally drew the lines and assigned the sounds. We built this specific toolkit just to make the universe intelligible to our human minds.
But here's the kicker. While we totally invented the symbols, it is incredibly hard to argue that we invented the underlying relationships those symbols represent. We didn't decide that two physical objects, placed next to two other physical objects, suddenly make four objects. We didn't invent that regularity. We simply discovered it and gave it a name. So humans may have invented the language of mathematics, sure, but mathematics itself might just be the language through which the universe's underlying structures make themselves known to us.
Which leaves us staring at a truly mysterious possibility. Perhaps mathematical structures exist even without a physical universe or human minds at all. And that brings us to one of the deepest debates in philosophy. If mathematical truths aren't physical things, and they aren't just thoughts in our brains, then what kind of existence do they actually have? I'll let that sit with you for a moment. Thank you so much for joining me on this explainer today. Until next time, keep questioning.